In this video, we're going to look at higher order derivatives. That is, when you differentiate a function, you actually get a new function. And when you differentiate your derivative, you get what's called a higher order derivative. So because a derivative is a function itself, you can differentiate it. When you take the derivative of a derivative, you get something called the second derivative. It can be denoted two ways, either f prime, double prime of x, or d squared y over dx squared. And nothing is really being squared here. That's just a way to write second derivative. The derivative of a second derivative, that's called the third derivative. We write that as either f triple prime of x or d cubed y over dx cubed. Then we have the fourth derivative, fifth derivative, so on. When we get to the fourth derivative, we stop using primes and instead we use parentheses around the number 4. Now if you just put f to the 4 of x, that means fourth power of x. But when you put f to the fourth in parentheses, that means the fourth derivative of x. Okay, we're going to do a simple example with a polynomial here. We're going to find the first through the seventh derivatives for y equals f of x, defined by x to the fifth minus 3x cubed plus x minus 8. So f prime of x is the first derivative. So we bring that 5 down, we get 5x to the fourth minus 3 times 3 is 9x squared plus the derivative of x is 1 and the derivative of negative 8 is 0. And now we can differentiate that. We can differentiate this derivative right here. So I'm going to bring the 4 down to multiply it times the 5 to get 20x cubed. The 2 times the negative 9 is minus 18x to the first. And the derivative of the 1 is 0. Then we've got the third derivative. So 20 times 3 is 60x squared minus the derivative of 18x is 18. And the fourth derivative, I could have put triple prime there, by the way, on third derivative. I just did that by accident there. So 60 times 2 gives us 120 x to the first minus the derivative of 18 is 0. Okay, let's do the fifth derivative. And you've probably noticed that the powers on the x's are decreasing with each derivative. We began with x to the fifth. The first derivative's highest term has a power of 4, or degree. Then the degree of the second derivative is 3, and then 2, and then 1. So you can guess what's going to happen here. The derivative of 120x is 120. But that's just a constant. So now the sixth derivative is simply 0. And the derivative of 0 is 0. So all remaining derivatives after this are 0. Now there's really not any uses for a sixth or seventh derivative. In technical engineering, there may be a use for the fifth derivative. I've heard NASA goes up to the fifth derivative when they are trying to land spaceships and put various parts together in outer space. It has to be a very smooth landing, so they don't want pieces bouncing off into outer space. Although that's just something I heard, and it's probably true though. Most of the time, we're really just going to look at the first and second derivatives because those are truly applicable. So just as the first derivative f prime of a function describes the rate of change of f, the second derivative f double prime, it describes the rate of change of the rate of change of f because we're differentiating the rate of change. Okay, so what does that mean? Well, it's helpful to look at some examples. So we're going to look at revenue first. For example, manufacturers, they experience variations in their flow of revenue. Sometimes revenue may increase, other times revenue may decrease. But regarding the second derivative, the question that we're looking at is if revenue is changing, how is the revenue changing? How is that revenue changing? If the revenue is increasing, it could be doing so at an increasing rate, or it could be increasing at a decreasing rate. So that means if your revenue is going up, but it's doing so at an increasing rate, that means it's going up faster and faster and faster. Or if your revenue is increasing, but at a decreasing rate, at least your revenue is still increasing, but it's increasing by less and less each day or each week or each month, however your time scale is. Or your revenue could be decreasing. If your revenue is decreasing at an increasing rate, that's really bad because your revenue is dropping off faster and faster and faster. Or if your revenue is decreasing but at a decreasing rate, that means it's slowing down but by less and less each day. Okay, so there's 4 possibilities here. The first and second derivatives of a function, they describe the trend in the function's behavior over some interval. So a function could be increasing but at an increasing rate, increasing but at a decreasing rate, decreasing at an increasing rate, or decreasing at a decreasing rate, right? And this is just a little bit more general. I'm not considering revenue right now. I'm just talking about a general function. And how do you tell? Well, the signs, SIG and S, of the first and second derivatives tell us which of these cases we're in. So if your first derivative is positive, that tells you your function is increasing. But if your second derivative is negative, for example, that means it's increasing but at a decreasing rate. Or if your second derivative is positive, it's increasing at an increasing rate. If your first derivative is negative, then your f of x is decreasing. But if the second derivative is positive, it's doing so at an increasing rate. Or if the second derivative is negative, it's doing so at a decreasing rate.